For the next few minutes, we're going to take a look at a few physics problems in mastering. We're on the instructor homepage, and I'm going to begin by clicking Calendar. And there I'm in the calendar of assignments that my students can see. We're going to open this item on the 28th. And in here we're going to open the one item in this assignment. And we're going to switch over to how a student would see this, but I want to point a few things out first. At the top, we've got a notice that says answer statistics on this page are updated periodically. Statistics were updated on July 27th, which happens to be today as I'm recording this. And what that really means is if we scroll down just a little bit, you can see nationwide results for this question. We can see how well students have done, percent who were correct, percent unfinished, the percent who requested a solution, and wrong answers per student. Now this is nationwide data. If you'd like to check after your students have done this, you'll see not only this nationwide set of stats, but also how your students did. Let's switch over to what a student might see. I'm going to go to Standard View, and before I start working in here, we're going to go ahead and restart the work. Now, don't be concerned. Your students won't have that restart work button. That's only something available to you as an instructor. Now, at the top left, we see the learning goal that your students are going to see. From this exercise, they should be able to calculate the components, magnitude, and direction of the resultant force of three coplanar forces. Three cables are attached to a bracket as shown in Figure 1. The figure's down there. The tensions in this cable are F1 equals 725 newtons, F2 also 725, and F3 725. I want to make a few errors along the way here as we play with this. For instance, here in this first part, calculate the horizontal component of the resultant force. Express your answer to three significant figures with appropriate units. I'm going to enter 261 newtons. And submit. Yes, I saw that. I know you did too. And it's telling me that the unit is not recognized. Now, how many times have you had a student enter Newton as lowercase n? I've got a list of acceptable units here. No credits are lost when the students look at this. And as we scroll down, of course, I'm looking for force. And when I toggle that open, we're going to see a nice alphabetical list of these. And your student is nicely reminded that Newton should be a capital N. So let me change that to the appropriate unit and submit. And lo and behold, we've got that one right. And let's take a look at the next part of this item. Calculate the vertical component of the resultant force. I'm going to enter 628 newtons, and I know now that that's capital, and submit that. Oh, I got that wrong. Apparently, I'd screwed something up in my thinking, and this is important for you to realize. The student is actually getting wrong answer feedback. In this case, it looks like they're told, hey, be sure you include the vertical component of all the forces. So let me update that after a little bit of rethinking to 435. I didn't change the unit, so we'll leave that alone. And let's close this and move on to our next example. Let's go back to all assignments. And now let's open this item, which is one of my favorite activity types. It's a coaching activity with a video in the question. Let's open that up. And once again, I'm going to get us to the standard view so we can see this like a student. I'm also going to restart my work. Again, I'll remind you the students can't do that. Now, I didn't point something out to you in that last exercise we looked at, but it was there. When you're looking at these items from the item library that are assignable for your students, each of them is going to have this icon at the top right. The last one had it. I just didn't point it out. Review. That review icon has got the image of a book open next to it. These are there not to give your students the answers, but for them to refresh themselves on the concepts. So if I click this within this particular question, it's going to take me to the part of the textbook, the e-text, that discusses the ideas they need to understand in order to be successful here. Let's open that. Now it tells me that it's going to bring me to Chapter 2, Section 3. If a student happens to have a paper textbook, they can simply turn to that page. We're going to open the e-text though. Now I'll remind you, we're not giving the student the answer to that question. We're simply bringing them to the relevant part of the textbook that will help them understand the topics they need, the concepts they need to really best understand this question. So let's presume the student has refreshed their memory and they're back here at this question. I'm going to open the video so I can really power through and get what my instructor wants me to understand.
In this problem, we've got a bracket which is riveted together, and it supports two forces. One of the forces we know everything about. That is the force on the top of the diagram. It's 60 pounds, and it's oriented at an angle of 30 degrees with respect to the negative x-axis. The other force has a magnitude of 70 pounds, but we do not know its orientation. It's given in the diagram by the angle theta. Our goal here is to define the angle theta.
Between my instructor's lecture, the textbook, and that lovely video, I'm pretty sure that the answer is F1 equals 14 pounds and F2 is 8.35 pounds. We'll submit that, and I'm correct.